Welcome to lecture 5 of design and analysis of algorithms. Here we will talk about time complexity, how to find time complexity of an iterative algorithm. So first of all, we would like to discuss how to find out time complexity. What are the basic steps to be considered? The time complexity of an iterative algorithm is measured in terms of frequency count. We have seen earlier also that why we calculate time complexity of an algorithm using frequency count method. Especially I'm talking about iterative algorithm. Now what is the frequency count? That also we have seen, but here to recall, it is a count denoting the number of steps or times of statement execution. Okay. So how to find the time complexity of iterative algorithms? We need to follow these 4 steps. Step number 1, try to identify the basic operations. Now, what are those basic operations? Like assignments, comparisons, then arithmetic operators like addition, subtraction, multiplication, and division. And then we'll count how many times, that is the frequency we're talking about here in frequency count. How many times each basic operation is executed as the input size n changes, right? Now input size, we will just denote input size by n or think in terms of n, okay? And then the third step is basically we will do what? We will analyze loops and conditional statements present in the algorithm. Primarily focus more on loop because that is where we will emphasize more to find out the time complexity of an algorithm. So finally what you will do, finally sum up all the frequencies of all operations and evaluate. If you find that okay, that is following a series, then evaluate it and then express time complexity in terms of upper bound if it is asked to provide the upper bound. Now we will discuss various examples. Through those examples we are going to look how we can compute time complexity of an iterative algorithm. So here find the question is find the upper bound of the time complexity for the following pseudocodes. Now here you see, so all the examples I have written, so I have used pseudocodes. So let's say here you see the first one, find median. This is a pseudocode that I have written to find out median. A is an array here, you see I have taken array of numbers, so A is already sorted, it is given in the comment. Now you see, let's take an array. Let's say the array is 10, 20, 30, 40 and 50. These are the array elements, let's say. Okay. So now these are the indices. Let's say I'm writing indices here. So index starts from 0, let's say. So 0, 1, 2, 3, 4. Now what is n? N is the size of the array. How many elements are there? 5 elements, n equal to 5. Now it is saying that compute q. Okay. So q is equal to, I have taken this example because here it is written that A is already sorted. Okay. Sorted examples I have taken. Okay. Now q equal to 0 plus n minus 1. N is 5, so n minus 1 is 4 divided by 2. So that will give me value 2, means index 2. Means it is saying that okay, return AQ. So when I am going to return AQ means what, I will get what? 30. So that is the median, right? Now you see, to compute this thing, what will be the time complexity? I mean, is there any loop you see? No, there is no loop. If there is no loop in an algorithm, finding time complexity is very easy. So this line computes the index of the median, and here it is going to return that median, right? So now I am going to say that okay, big of 1, and then this is also big of 1. Okay, return AQ. If I ask you that why it is not going to depend on the input size n, because you know when I am writing big of 1 means what, it is not dependent on input size n. If you increase the number of elements here, okay, let's say I'm increasing the number of elements. No, there are 99 elements, let's say. So at last index will be here what? Last index will be 98. Okay, let's say 175 is present there. Okay, so then also in that case, if I'm going to compute the median, then also it will be what? 0 plus first plus the last one, that is for 98 divided by 2. So it will give what? It will give 49, right? Now you see, in this case, I am increasing the array size, means I am increasing n. N changes from 5 to 99, but time complexity is not going to change because it has to do the same thing. It doesn't matter you increase the size of input or not. So it is called constant time complex. So what will be the time complexity for this algorithm? In example 1, it will be n equal to big of 1 plus big of 1, that is nothing but constant. So we can write n equal to big of 1. So that is our answer in example 1. So now for example 2, so here there is a loop. So directly we will focus on loop because the time complexity will be decided by the statement or the statements inside the innermost loop. How many times the statement or statements inside the innermost loop executes, that will decide the time complexity of the algorithm. So here there is only one loop. So this loop, how many times this loop is going to execute, that will decide how many times the statement inside the loop will execute, and that will be our time complexity. So first of all, understand in detail, because this is our for I equal to 0, I less than n, I plus plus. This is our loop, right? So now, since it is our first example, so we'll go in detail. Okay. So here, don't care about the syntax. I'm telling repeatedly. Just we need to focus on the concept. So I equal to 0. So how many time it will execute? Only one time. Yes. Only one time it will initialize. I less than n means when I equal to 0, it will check 0 less than n. Yes. If it is true, then only it will go to increment I, right? Now here, next time I will be incremented, and again it will check, let's say I equal to 1, then 1 less than n. So like that it will go. So this statement itself, I less than n, okay, this is going to run for what? N times, right? 0 to n minus 1. So 0 to n minus 1 is n. So n times it is going to execute because it has to check every condition. But here one small thing, like actually it is going to run n plus 1 time. Why? This plus 1, this time it will check the condition and it will find that the condition is false. When the condition is false, the variable I will not be incremented, and the statement inside the loop will not be executed, right? So actually it is going to run for n plus 1 time. I plus plus, this statement, this will execute n times. So I will sum up, okay, n plus 1, that is what? Twice n plus 2. So total twice n plus 2 steps, or twice n plus 2 times this will execute this loop. So in terms of big O, if I write, so you know that if in terms of asymptotic notation like big O, if I write, so I don't care about the constants and lower order terms, so it will be directly what? Big O of n time. So from now onwards, I am not going to discuss in this detailed manner because you understand now. So directly I will write, if this kind of thing I see, that directly I will write in terms of asymptotic notation like big O. So it will be big O of n, right? So now you see, if key equal to ai, if this condition is true, then we will return I, right? So this condition will be checked how many times? This condition will be checked big O of n times, right? Okay. So when this condition is true, if it is true, then only it will return, otherwise it will not return. So it is not going to run n times, it is going to run only constant time. It will also be constant time. So if I add now in terms of big O, if I write, so I will simply write big of n, right? So this is our answer for question number 2. So example number 3 now. So in this third example, from now onwards, I am not going to write the function name like here I have written. Okay. So just I will focus on the loop. Now you see the time complexity of this, it will be decided by the statement inside the loop. How many times this statement is going to execute, that will decide. But this statement is under this loop, so it is dependent on this loop. So now we need to find out how many times this loop is going to execute. Okay, so then easily we can find out. You see. Now, first of all, we will analyze this way. I equal to n, okay, and then always look how the value of the loop variable is going to change. Like here you see I equal to I by 2 means first of all I equal to n, and then I by 2 means what? Next value will be n by 2. Next will be what? N by 2 means n by 2 square. Next will be what? N by 2 by 2 by 2 means n by 2 cube. Like that it will go. So where it will stop? Let's say it is going to repeat these things and it will stop at n by 2 to the power k. We do not know k now. We need to find out k, right? So now, but one thing we know that it will stop, the loop will stop when I will be what? Less or equal than 1. Because, up to the point where I greater than 1, it will execute. And then when I less or equal than 1, then this loop will stop, right? Means what? This thing n by 2 to the power k, if it is our stopping point, means what? N by 2 to the power k, this should be equal to what? 1. Actually, this should be less or equal than 1, right? Because here it is greater than. So stopping criteria is this one. Now let's say n by 2 to the power k equal to 1. So if I find out 2 to the power k, so it will be equal to what? N. So k we do not know, so what is k? K will be equal to big O log n base 2. So log n base 2, we can write LGN, that is nothing but log n base 2, shortened form, right? Okay, so here this loop, for loop is going to run for what? Big of log n times. So the statement inside this loop is also going to run big of log n times. So now, as I told you earlier that the statement inside the loop, how many times the statement inside the loop executes, that will decide the time complexity. So what is the time complexity here? So statement inside the loop, that is print algorithms. Okay, so this will run big of log n times. So this is nothing but our answer. So what is our answer in this case? Answer in this case is what? Big of log n. Now remember one thing. When you will encounter that something is repeatedly divided by a factor, always think about logarithm. Here you see n is repeatedly divided by a factor what? 2. Okay, here n is divided by 2 to the power 0, here n is divided by 2 to the power 1, like that it is going. So you can directly write log n base 2, right? N is what? N is the input side here. Okay. Now example 4. So here the statements, those are not on the loop, those are going to take only constant time. We have seen now. Okay. So now here you see the time complexity of this algorithm will be what? How many times the statement inside the loop is going to execute, that will decide the time complexity. Means what? We need to find out how many times this loop is going to execute. Okay. Then I equal to 1. Okay. How it is changing? How I is changing? Next will be what? I into 2 means what? Next time it will be 2. And next it will be 2 square, right? Next time it will be 2 cube. So that way it is going to change. Let's say it is going to stop at 2 to the power k. We do not know k, but we know what? The stopping criteria. That will be I greater than n. Because up to I less or equal than n, this loop will run. And when I will be greater than n, loop will stop. Okay. So this, if this is our stopping criteria, means what? 2 to the power k, 2 to the power k greater than, should be greater than n, right? Now let's say for simplicity, you can assume that 2 to the power k is equal to n, approximately you imagine in that way. So what is the k? Because anyway we are going to provide upper bound, so it doesn't matter in that sense. So k will be equal to, if I want to calculate k here, that will be log n base 2, right? So log n base 2, we can write LGN. Okay. Now this loop, so we know now k. Okay, so this loop is going to run what? Big of log n. Okay. So if this loop is going to run big of log n, the statement inside the loop is also going to run big of log n times. So what is the time complexity now? So time complexity Tn is equal to big of log n. Now question number 5. So this is the answer for question number 4. Question number 5. So here also you see the statement sum equal to 5. It is not under any loop. So it is what? Big of 1, right? So here in this case, the time complexity will be decided by how many times this statement is going to execute. Okay. But before that, we need to analyze the for loop, right? So here you see, in this case, I is equal to 1, and I will change linearly. I equal to 1, 2, 3 like that. But if I square less or equal than n, you need to imagine in that way, right? So how we can write it? I is less or equal than what? Square root of n? Yes. So here you see, I is running from 1 to square root of n. This loop is going to run for big of square root of n times, right? So if this loop is going to run for big of square root of n times, this statement is also going to run for big of square root of n times. One less than that, in that way we have seen earlier, but I am writing in terms of big O. So do not get confused with those things. Okay. So that what is the time complexity? So time complexity for this question number 5, Tn equal to big O square root of n. So this is our answer here. This way you need to analyze to find out time complexity of iterative algorithm. Focus on loop. Okay. Now here also in question number 6 you see sum equal to 0. So big of 1 it is, okay, constant because it's not under loop. Here you see the time complexity of this algorithm will be decided by the statement inside innermost loop. Why I am saying so? Because there are more than one loop. Two loops are there, right? So in this kind of question, how we are going to provide the solution? Here you see I equal to 1 to n, and every time I is incrementing, I equal to I into 2. So we have seen, just now we have seen here in question number 4, I equal to 1, I less or equal than n, I equal to I into 2. So this way if it goes, so this loop will run for log n times. So simply I will write here what? Big of log n, because this loop is going to run for big of log n times. Here we have seen how it is done. Now the next time here you see this loop for j equal to 1, j less or equal than n, j plus plus, itself it will run itself what? How many times? J equal to 1 to n, right? So n times it will run. So this loop will run n times, but for each value of I, this loop is going to run for n times. And this loop, outer loop, is going to run big of log n times. So log n into n times, right? So n into log n times. Okay, nested loops. So in case of nested loops, there will be multiplication. Okay. Now the statement inside the loop, this one, it is going to run for big of n into log n times. Okay, so that is our time complexity. So what is time complexity? Tn equal to big of n log n. Okay. So question number 7. So here you see the time complexity will be decided by the statement inside the innermost loop. So here innermost loop is what? This one. The outermost loop here you see this loop is going to run from I equal to 1 to n. When you see I plus plus, it is very easy to calculate. You see, you will just see the initialization and the stopping criteria. You can directly count because it is going to change linearly. I plus plus, like I equal to 1, then 2, then 3, like that it will go. But when increment or decrement is not linear, then you need to focus more to find out the pattern, right? So here in this case, it is very simple that this loop is going to run from I equal to 1 to n. So total how many times? Total it is going to run for n times, right? So I will say rather this loop is going to run for big of n times. Okay. Similarly, here you see this loop j equal to 1 to n, j plus plus. Here also j is going to run n times, right? So again here it is in terms of big O if I write, so again here it is going to run big of n times, right? Itself. But this is the inner loop. The outer loop is this one. So here will be what? N into n. So this loop will run n square time. Why? Because when I will be equal to 1, this loop, innermost loop will run n times. When I equal to 2, it will run n times. When I equal to 3, it will run n times. So when I is going to run n times in total, so this innermost loop is going to run big of n square time. So how many times this statement inside the innermost loop is going to execute? This is big of n square. So if I want to find out time complexity now, then Tn will be equal to big of n square. So this is our time complexity for this. You can calculate this way also. When I will be equal to 1, how many times A is going to execute? N times, right? This is n times, right? So when I will be equal to 2, when I will be equal to 2, then also J is going to execute n times. Like that it will go. So when I will be equal to n, then also J is going to execute n times, right? So how many n's are there? N n's are there. So that will be multiplied, n will be multiplied with n. So that way also you can compute. But this is the simple one. Okay. Anyway, so in question number 8, we're going to see how we're going to find out the time complexity for this one. Here you see the loop is while loop, right? First of all, understand this, S, condition is what? S is less or equal than n. While S is less or equal than n, this thing will happen, right? So, first of all, S is initialized with 1, right? And then here I will write I. So, I is also initialized 1, right? Next, here you see S less or equal than n. So, 1 less or equal than n. Let's say n is some value there, okay? First of all, I will be incremented and S will be incremented, but S is dependent on I. Increment of S is dependent on I. So if I equal to 1 next, this line will be executed. So I will be equal to 2 next. But what will be S? S will be S plus I. So 1 plus 2. 1 plus 2 is 3. So S will be 3. So next I will be equal to 3. S will be equal to 3 plus 3, 6. Next, I will be 4. So, S will be 6 plus 4, 10. So, is there any pattern we are observing or what? S is N. Okay. Now, how many times I is executing we do not know here. Let's say K times. Why? Because it is not linear, you see. S 1, then 3, then 6, then 10. So here we are not observing anything here, okay, so that we can directly say, okay. But one thing we know that what is the stopping criteria? Stopping criteria is what? Stopping criteria is s greater than n, okay. Now the increment of s is dependent on I, here you see. So we need to see how many times I is going to execute. So what is that? 1 plus 2 plus 3 plus 4, like that it will go up to plus k. Okay. So this thing will be what? This will be greater than n. S is dependent on the increment. Now it is what? The series k into k plus 1 by 2 greater than n. Okay. So here what I can find out? We need to find out what? We need to find out k, right? We do not know k. So from here, if you want to find out k in terms of asymptotic notation, okay, k square plus k, it will be divided by 2. So asymptotically if I write, so k square will be greater than n. So k is equal to big of square root of n. Okay. So the statement, this one, print algorithm, this is going to run for big of square root of n, right? So what is the time complexity for this algorithm? The time complexity for this algorithm is what? Tn is equal to big of square root of n. Okay. So you need to analyze for this kind of pseudocodes to calculate the time complexity very carefully. Okay. For while loop, try to match with the for loop. Okay. To understand more and see the dependency as here we have seen. Okay. Now question number 9. So in question number 9, you can see, you can observe what you see here. I equal to 1, I less or equal than n, I plus plus. So we understand that, okay, this loop is what? This loop is going to run big of n times. But here you see j equal to 1, j less or equal than n, but here increment is what? It is depending on I. Okay, now let us analyze. I equal to 1, when I equal to 1, how many times j is going to execute? J is going to execute n times, right? Because 1 to n, right? N times. Next, when I is equal to 2, increment I. Now when I equal to 2, now how many times j is going to execute? Because here you see increment is what? J equal to j plus I. So j equal to j plus I. Here the step is not 1, step is 2. Okay. So it is skipping one step. So if it is going to skip one step, step j will take n by 2, right? Why? Because it is skipping one step, alternate step it is taking. Okay. Similarly, when I will be equal to 3, when I will be equal to 3, j will be equal to what? J will be equal to n by 3 times, right? Like that it will go, like that it will go. So I will go up to what? I will go up to n. So when I will be equal to n, j will execute how many times? J will execute n by n times, right? Now, in total, how many times j is going to execute? Now, dependency we have just resolved here, right? This dependency we have seen here. Okay. So you just sum up this thing. So if I sum up, so if I take common n, so it will be what? 1 plus, here it will be 1 by 2 plus 1 by 3, like that it will go. Okay. Dot 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 plus. If I take common, so it will be 1 by n. So what is the sum? N into this thing, you see, this is nothing but what? This is log n. So n into log n, right? So what is the time complexity of this algorithm? The time complexity of this algorithm is what? The statement inside innermost loop is going to execute n log n times. So what is the answer? Answer is Tn equal to big of n log n. So this is our answer for this question. Okay. Now here I have written Here I have written log n. So how I can write log n there? It is harmonic series, right? So if you see, just remember this result is very useful result. So here I am writing. So if you find 1 plus 1 by 2 plus 1 by 3 plus it is harmonic series plus 1 by n. So if you find out the sum of that thing using formula, so this will be equal to log n. Okay, this is very useful result. Okay, just remember that thing. Question number 10. Okay, the time complexity of this pseudocode or this algorithm is going to depend on how many times the statement inside the innermost loop executes. That will decide the time complexity. Yes. Now here you see I equal to 0. We need to analyze to find out I equal to 0. When I equal to 0, how many times j is going to execute? 0 to less than n, right? So j is going to execute what? I to how many times? I to n minus 1, n minus 1 time. And I is going to execute 0 to, okay, here you see, this way we will find out 0 to n minus 1. So total how many times I is going to execute? N times, right? So total how many times j is going to execute? I to n minus 1. How many times? N minus 1 minus I plus 1. Because values are inclusive, right? So last minus first plus 1, right? So here also you say n minus 1 minus 0 plus 1. That is nothing but n. Because you need to include 0 also, right? 0 to n minus 1, how many terms are there? N terms, right? So similarly here n minus 1 minus I plus 1. So this is what? N minus I 10. And k, now okay, let's go to k. K is j plus 1 to n minus 1. Okay. So here it is j plus 1 to n minus 1. So here if we want to find out what will happen, n minus 1 minus j plus 1 plus 1. So here if we find out, I mean we are trying to find out how many terms are there, how many time it is going to execute. Here it is saying that j plus 1 to n minus 1 it will go, and j is going to run from I to n minus 1. I is going to run from 0 to n minus 1. That way we are going to find out. This is the easier way of finding out, right? So if I find out here, so it will be what? n minus j minus 1 time, right? Now this is the innermost loop. So the statement inside the innermost loop, how many times that will execute, that will decide the time complexity. So we are going to focus on this one. Right here you see, we have written the expression in terms of what? I and j, right? So here you see, summation I am writing in terms of summation. You see, or you can directly sum up also. Okay. I equal to 0, I is going to run from 0 to n minus 1. Okay. And then what? J is going to, j is equal to I to n minus 1. Okay. Now, how many time k is going to execute? That is going to decide the time complexity, right? Because that is the innermost loop, right? So n minus j minus 1. Summation I equal to 0 to n minus 1. So here I can write n minus 1 minus j. So if I do that, it will be what? J equal to I to n minus 1. We can write here n minus 1, okay, minus this whole thing under this one, minus summation j equal to I to n minus 1. Here it will be j, right? So n minus 1 minus j. We have separated this thing. Okay. So if you find out this one, there is a formula times what? n minus 1 times n minus I. How it is so? Because there is a formula, you see, summation is something like that, j equal to k to n. Let's say here it is 1. So the formula is n minus k, okay, n minus k plus 1. So here if let's say instead of 1, here it is let's say n, okay, then it will be what? N into n minus k plus 1, right? Now here similarly if I find out, so n minus 1 minus I plus 1, so that is n minus I and times n minus 1, right? So this formula is important, okay. And this one if I evaluate, so what I will get? N minus 1 plus I into n minus, you just evaluate it to find out, divide by 2, n into n plus 1 by 2, that formula, okay. So if I put it here and evaluate, so this whole thing will be evaluated. So here it is summation I equal to 0 to n minus 1. So these are inside this one. So if I evaluate, so I will simply find big of n cube. Okay. So you'll get an expression. From there you will write in terms of asymptotic notation like big of n cube. So this is the time complexity. So what is the answer for this one? So for this one the answer is Tn equal to big of n cube. So this is the answer. This is the time complexity. Okay. So in question number 11, this one sum equal to 0. This is going to take constant. Okay. Step. So now we need to analyze this loop and the loop inside this one. You see, this loop, okay, surely it is going to run for n times because increment is linear and it is going from 1 to n. But this one, j equal to 0, here you see, here there is a dependency. J is less than I. It is not in terms of n. Okay. So we need to analyze. Okay. So I equal to 1. When I equal to 1, so how many times j is going to execute? 0, j equal to 0 to less than I. So when I is 1, so less than 1 means from 0 to 0, 1 time, right? When I will be equal to 2, because increment is linear here, j is going to run 0. First of all, j will be 0 and then 0 less than 2, yes, fine, it will execute. Again, j will be incremented. Here increment is also linear. And again, j will be incremented to 1, then 1 less than 2, it will execute. Means what? J will execute 2 times. When I will be equal to 3, similarly, j will be executed 3 times. Okay. So like that it will go. So when I will be equal to n, j is also going to execute n times. Right. So in total, how many times j is going to execute? That will decide how many times the statement inside the loop is going to execute. So 1 plus 2 plus 3 plus up to n. So if I add, that is what? N into n plus 1 by 2. So if I write in terms of asymptotic notation, we go n square plus n divided by 2. So highest order term I will take, and discarding all the lower order terms, it will be what? Big of n square. Okay, so how many times this statement inside the loop is going to execute? Big of n square. So what is the time complexity for this algorithm? Tn is equal to big of n square. Okay. Now focus on question number 12. Here also we will analyze the same way. When I equal to 1, how many times j is going to run? J equal to I. Now here you see decrementing loop. J equal to I and then j greater than 0 means what? J greater than 0 means what? 1 to I. So 1 to I is what? I times, right? So here also same. So j is going to run just the loop is decremented loop, right? Here is the value is decrement. So here the value was incremented. So similarly, when I equal to 2, so j is going to run 2 times, like that it will go. So I is total, in total I is going to run n times. So j when I equal to n, j is also equal to n times, right? Okay. So in total, how many times? So 1 plus 2 plus 3 plus, like that it will go up to n divided by 2. So this we have just seen here, that is what big of n square. Okay. So the loop, this loop is going to run for big of n square times. The statement inside the loop, print algorithms, it is going to run big of n square times. Yes. So what is the time complexity? Tn will be equal to big of n square. So this is our answer. Okay. Move to the next one, question number 13. So in question number 13, so here it is given I starts from n, I greater than 0, I equal to I by 2. How the value is changing? Here you focus. Okay, it is not linear. So first of all, I will be equal to n. When I is equal to n, how many times j is going to run? J is going to run from 0 to I minus 1, means what? J is going to run for I time. So when I equal to n, j will be equal to what? N times, right? Next, when I will be, next value of I is what? N by 2. So j is going to run for what? N by 2 times. Because j is going to run from 0 to I minus 1. J is going to run for 0 to I minus 1. 0 to I minus 1 is, now how many terms are there? I minus 1 minus 0 plus 1. That is what? I, right? So next value, n by 2 square. Right, here also it will run n by 2 square, like that it will go. But when it is going to stop? I, when I less or equal than 0. Okay. So here you see how we are going to find out how many time j is going to execute, because it is not, increment is here the increment of I is not linear and j is depending on I. Here you see j is dependent on I. Okay. So here it is what? N plus n by 2 plus n by 4 plus, like that it is going to go. And so here if I think about this summation, okay, let's say this is GP series, right? GP series, a by 1 minus r, what is the common ratio? Common ratio is half, right? So this is equal to 2n. So if I write in terms of big O, it will be big of n, because I don't care about the 2 when I am writing in terms of asymptotic notation. So if I say how many times this statement is going to execute, print algorithm, this is going to execute big of n times. Okay. So what is the time complexity for this? Tn equal to big of n. So question number 14. So in question number 14, I is 1, j is going to run from 1 to less or equal than I. So 1 to I means what? I times, again the same thing, 1 time. I equal to 2, then j 2 times. When I is 2 square, j is going to run 2 square times. So that way it will go. Okay, what is the stopping criteria? When I will be greater than equal to n, right? So let's say it is greater than equal to n, it is going to stop. Okay, 2 plus 4 plus up to n. So it is what? It is, if I find the summation, so I will get what? 2 n minus 1. Okay, so this if I find out in terms of asymptotic notations, I will just write n and discarding all other constants and lower order terms. So what is the time complexity for this one? Means what? This print algorithm, this statement is going to run for what? Big of n times. Okay. So it is also Tn equal to big of n, right? So this is the answer. Now 15. Now here in question number 15, if you see very carefully, I is initialized, I is initialized with n, right? And then condition checking I greater than 0, and how the value of I is changing, value of I is changing, I equal to I by 2. Now if you remember, we have seen this kind of thing before. So if I just replace this while loop with the for, so what I can write, instead of writing this while loop, if I convert it into for loop, because that will be easier for us, because we have seen so many things using for loop. So it will be what? I equal to n, okay, then I greater than 0, then what? I equal to I by 2. Now if you remember, this kind of thing already we have seen. So this is going to run for log n times. Okay. So if I write in terms of big O, log n times. So in the earlier questions we have seen, like n, why it is log n time? Because I will be n, the next time I will be what? N by 2. So next time I will be what? N by 4, like that it will go. Okay. When I less or equal than 0. So like that it is going. So here you see, n is getting divided by 2 every time, you see. So approximately we can say in this way that it is going to run for big of log n time. The statement inside the loop, while loop, okay. So how many times these are going to execute? Big of log n. So and this statement return sum is big of 1. So here also this is also what? Big of 1. So constant term, those whether you write or you do not write, that doesn't matter. Okay? Anyway, those are lower order terms and those will be eliminated anyway in asymptotic notation. So what is Tn? So Tn is equal to the highest order term. Here is what? Big of log, and Tn means what? The time complexity of this algorithm that we have seen. We are denoting that using Tn. Okay. Now we are going to discuss about consecutive loop. Okay. So in question number 16, you see here, this we can think about. This is one part, and this is another part, right? Here is why I'm separating in that way. These are consecutive loops, right? So these two are nested loops. This for loop and this for loop, nested loop. But with this for loop, the outermost for loop here, these are consecutive loops. So in consecutive loop, how to find out the time complexity? So I have taken two examples here. So we will discuss these two examples to understand if there is consecutive loop, how we can find out the time complexity for those. Okay. So here we can clearly see that I is equal to 1 to n, and increment is linear. So how many times this statement inside the loop is going to execute? So that is going to execute for big of n times, because it is going to run from I equal to 1 to n. Now here you see how many times this statement inside the loop, innermost loop, that is print algorithm, is going to execute. Okay. So for that thing we need to analyze this innermost loop. Now see, when I will be equal to 1, j will run for n times. I equal to 2, j is going to run for again n times. So like that it will go. So this outermost loop is going to run big of n times. The innermost loop is going to run big of n square times, because big of n into big of n. Okay, I am writing in terms of big O. So I will write big of n square. So now here you see the statement inside the loop will execute big of n square times. Okay. So here, instead of writing this all, I will write big of n square. Why? This statement is going to execute big of n square times. Now what to do? Multiplication or addition? That we need to understand. You see, these two were nested loops, and we already dealt with the nested loop. And we found that in this block we will find big of n square. Now in this block, we have separated in blockwise to make it easier. Okay. So in this block it is big of n. Now you see, since it is consecutive, the loop here it is what? Consecutive. Consecutive. C-U-T-I-V. Consecutive. Okay, if the loops are consecutive, then we will add, right? If the loops are nested, then only multiplication. We have seen. So big of n plus, here it is big of n square. So if we find out the answer, that is nothing but big of n square. So what is the answer here in this case? Question number 16, the answer is big of n square. Okay. Similarly here also in question number 17, question number 16 solved, question number 17, here you see, if you think this is one block you can think about, here also you can think about this block, okay, and then we know that return false, this is going to run constant time, it is not going to depend on input side. Now here you see this loop here, it a bit differently I have written. Here you see, generally we write in programming languages like this way, as we have seen in the earlier examples. Now we can, because it is pseudocode, so we can write anyway, you see, but we need to provide a clear picture, that is our goal. So here it is clearly saying that I is going to run from 1 to n. What is the step size? If the step size is not written, just think that it is linearly going to increment the value of I. Okay, so I equal to 1 to n, and the increment is linear. So it is going to run big of n times. Yes. Now if this condition is true, then only it will return. So individually this if statement will be checked big of n times, and then return true, that will be constant, right? If it is so, then return true. If this condition is true, then return true. Okay. So likewise here also for this block, here also I is going to run n time. Okay, the statement inside the loop, those are going to run for n time. So here also the loops are consecutive loops instead of nested loop. So big of n plus big of n. So if we write the answer, it will be what? Big of n. So what is the answer in this case? The answer in this case for question number 17 is big of n. So this is how we need to find out the time complexity of iterative algorithms. Iterative algorithms, why I referred, because in iterative algorithms, the loops will be there, iterations will be there. So this is all for this lecture. Thank you very much.